We've looked at the various gates that we can use. Today we're going to look at how we can put them together and have expressions with them. Write them out as Boolean expressions as well as schematically. So say you have A, B prime plus C. How would you do the schematic from that expression? Well, you go by the order of operations. The order of operations are parentheses first, then the nots, ands, then ors. So there's no parentheses in this expression. So you do the next, the nots. And when you draw out a schematic from an expression, you start from the left and work to the right. So not B would be having your, let's say you have your inputs here. Not B, run it through an inverter. That takes care of your B input. Then your and that with A, and then you do your ors, your C, or that with your C. And that gives you your out. All right. So you work your order of operations and do everything from left to right, inputs to outputs. Right. So say you have A, B, or B, C prime. You have your A, B, and C inputs. And you start with your parentheses. A and B, B and C. In the order of operations, what comes before the and, but the not. And then B with anded with that, and then or, like so. An input can be used in multiple locations, like it is here. You just split the line, connect it to the appropriate gates in the expression. Let's see here. Do one last example of this. A or C prime and B, C. In this case, we can do the parentheses first again. A, B, C. C is ORed with A. Then it is inverted. And then that's ANDed with B and C. Okay. Now let's see if we can go the other direction. Let's see if you can see about how we can get a Boolean expression such as this from a schematic. Let's see here, A, B, C. You would start from the left and create your expression. So you would start from the left, which is an OR gate, B, A or B. Put that in parentheses. And that's inverted. And then that is ANDed with C. So work from the left to the right, create your parentheses, and do your order of operations accordingly. Where, let's see here. Something a little bit more complex. What would we do first on this? What would we do first in this to draw the schematic for this? I mean, to do the Boolean expression for this. What's the leftmost symbol? The inverter? Huh? Yeah, the inverter, the not. So not B. And what are we doing with that? ANDed with A. Okay. So we can put that in a parentheses. And then add the OR gate. This right here. Do the OR gate here. That's going to be another parentheses. That's B or C. Now you have the two parentheses here. We're going to AND those together at the end. If you're being consistent, I suppose you should put a star here. But all right. And now we're going to see if we can do a state table for one of these. We looked at doing state table. Yes. And that's a star B, A star B.
Yeah, this one.
Oh, okay, yeah.
So how do you know when you should do the?
Oh, you could, yeah, you could use a NOR gate here, but yeah, or the inverter, yeah, yeah. In the lab class, you'll only have ands, ors, and nots. You won't have NOR gates. So I do it out like this. I covered the NOR and NAND gate for the sake of completeness earlier last week. So let's look at this one. Creating a state table from the schematic. We did that somewhat before. You just start with the A, B, C, and do all your combinations. Counting binary here. That's here, that's 4, okay. And you're out. So, I'm sorry, A ORed with B is going to be 0, 0, and then 1s all the way down. So we'll go A or B, be 0, 0, 1, 1, 1, 1, 1, 1. And then A plus B prime, primed, A 1, 1, 0, 0, 0, 0, 0, 0. Right? When I ask right, I do actually mean that. It's like, because I'm not infallible, I will make mistakes occasionally. I try not to, but it happens. And then the out is going to be this column ANDed with this column, the C column. So it's going to be 0, 1, 0, and 0 all the way down. All right. Without realizing it, I made what is called a selector, where it selects one particular input, combination of inputs, and is high for that one particular combination, and low for all other combinations. So this is a selector. For 0, 0, 1. Everybody see how I did that? We did this, like I said, last week, a couple of times. You know, following through the schematic, highs and lows, or zeros and ones. So, all right. Let's go ahead and look at this other one down here. Might as well keep this up here because it's still A, B, and C. Got B prime, which is 0, or 1, 1, 0, 0, 1, 1, 0, 0. Right? Just the invert of the B column in this column. And then A star B is going to be, or B prime, sorry, is going to be zeros and 1, 1, and 0, 0. Zeros because the A's are all zeros here. And 0 ANDed with anything is going to be 0. These two, the A is 1 and the B is 1, so those are 1. And now the B's are 0, B primes are 0, and A is 1. So that's that. And now B and C, B or C. B or C. B or C is going to be 0, 1, 1, 1, 0, 1, 1, 1. Okay. And it looks like this might be another selector, because you're going to AND these two columns here in the output. And it's going to be a 0, 0, 0, 0, 0, 1, 0, 0. So it's another selector. This time it selects when A and C are 1 and B is 0. So this is also a selector output selector. I'm sorry? The out? The out is the AND of the first parentheses ANDed with the second parentheses. So it's the AND of these two. So 0 and 0 is 0. 0 and 1 is 0. Likewise, likewise. 1, 0 is 0. 1, 1 is 1. 0, 1, 0, 1. Mm-hmm. And there you go. Now how about we look at how to make a schematic from a state table. Bless you. All right. So we'll erase all this. And let's say you're out. You want to out here, here, not here, not here, here, and none, and no out, and low for the rest. So you have 3 states where the output should be high or 1. Okay? So it's either this combination or this combination, or this combination. Notice the use of the word or in that description. So you're going to have this or this or this is going to be the result. So you're going to have 2 or operations. Now, what is this? A combination of and. This is 0, this is 0, and this is 0. So that would be A prime and B prime and C prime. A is 0, and B is 0, and C is 0. To make that all true, you make them, you invert them, so it's A prime is 1, A B prime is 1, and C prime is 1. that makes that a 1. That parentheses evaluates to a 1 in that combination. Yes. Because there are 3 possible outputs that there are 1. So it's either this combination of inputs, or this combination of inputs, or this combination of inputs. There's 2 ors there. Okay? And then this is looking at this is 0, and this is 0, and this is 1. So you would have A prime and B prime and C. A is 0, primed is 1. B is 0, primed is 1. And C is 1. Don't make it prime, just leave it as a 1. And that gives you the AND gate, the AND expression. Now how about this third one? What would that one be? This one right here. That's right. A, B prime, C prime. There's your expression. Now when we get into Boolean algebra, we'll see how to make it a more simple expression. Yeah. Oh, this is a structure that's very common and basically a standard. It's called the sum of products. Form. Because and looks like a multiplication, and or looks like addition mostly. So it's called the sum of products form. And there is another form that's not as commonly used. It's called the product of sums. Where you would have, say, A or B plus or times C or A star B or C. See how that's a product of sums? It's a product of these sums. This isn't that common. You don't see that very often. You're more likely to see this. But we'll get more into that and when we get into min terms and max terms and all that sort of fun stuff. I'm just giving you a little foreshadowing here. But when you see this type of structure, you can easily reduce the amount of gates when you draw a schematic of this. So You have A, B, C, and what you do is you run an inverter off of each one, because each one is inverted for one of the terms. And you have A and B prime, A prime and B prime in two places. So you can do A prime and B prime ANDed together. With C prime and with, this is going to be kind of messy, but with C and then A. Oh, I guess you don't need B. A and C prime and and B prime. A and C prime and B prime. Like I said, this is kind of messy. And then 4 and 4. Like I said, it's messy, but should be right. I would recommend when you're drawing on your computer using KiCad or similar software. You can drag things around, manipulate symbols and all that sort of stuff to create cleaner schematics. Yes. I'm sorry? Oh, okay. Yeah. Eagle is a very good software, but the student version is very limited as to what you can draw. I mean, you could use it. It'll be sufficient for your lab class, but KiCad is becoming better as it's an open source. Yeah. Oh, yeah. Sorry. And it's KiCad.org is, if I'm not mistaken, the website for it. But yeah, this here. This is a joint. This is a joint. This is a joint. But if you plan out your schematics, you can make them more clean. But you should be able to create schematics from a state table, create a Boolean expression from the state table, and then the appropriate schematic goes with it. But let's see here. I think that was going to be about it for what I was going to cover today. There will be a quiz on Friday. covering gates, state tables, and what we covered today. There will be no class on Wednesday. I will be traveling. I will be out of town. So enjoy the day off. Do some studying. Review the videos. Again, they're on YouTube. I don't have the access to Canvas again yet. So I haven't been able to put the links in the announcements. Have a good day.